Martlesham engineers have developed a new compact telephone exchange providing 600 lines, which makes it ideal for use in rural areas. The UXD5, which is fully digital, will be unattended, thus providing an economic service with the advanced facilities of a large-scale digital exchange to our rural customers. A computerized maintenance and diagnostic system will ensure secure and trouble-free operation without the need for expensive site visits.
This is our SwitchStar cable TV system. As well as the 4 main network channels, you can receive movies, sports, pop videos, and a local videotex service. One of the exciting developments is Video Library. With this, you can choose to watch a program when you wish. You can also even stop or scan through it if you so desire. These are the video disc players used to provide programs for the video library. This is the kind of setup one might find at the head end of one of our cable TV systems. And these are the off-air demodulators and videotape players used to provide some of the other channels. Here's an interesting development. You might soon see a video jukebox like this in your local pub. You may well ask what it's got to do with cable television. Well, with the development of this, you will soon be able to access an even wider range of programs on the video library.
The move towards miniaturization has led to the development of machines that can automatically select and surface mount components. A program loaded from a microcassette controls tool changes, picking of components from reels of tape, and accurate placement on printed circuit boards. This particular machine can place up to 60 different components in a sequence of up to 800 operations at a rate of up to 5,000 per hour. The fully automatic surface mount assembly factory is one step nearer.
What you see here on the screen behind me is a 3-dimensional representation of a telephone handset designed on this system. The picture shows the machine path necessary to cut off a model of it or to actually cut the machine tool. What we do is we design the actual telephone handset, the shape of it, the visual aspects on the screen. We can then use tapes to cut off models such as this, and ultimately the tapes can be used to cut machine tools, which then can be used to mould the plastic piece parts of the telephone handset. Here we can see the finished product of the telephone handset from the model.
The Human Factors Division at Martlesham is concerned with harmonizing the work of man and machine. Network management centers will enable staff to monitor the flow of telephone traffic and take control of rerouting in overload conditions or in the case of a serious fault. Human factors are involved in workstation layout, environmental assessment, work organization, and the design of graphic displays. Another project is the ergonomic evaluation of VDU terminals to ensure that screen and keyboard characteristics are designed for maximum comfort and minimum fatigue.
Yes.
Work is also in hand to develop a system that will accept word commands from any number of callers.
Ipswich.
A big step forward, as existing speech recognizers have to be trained by a specific voice.
Ipswich.
In this laboratory, we're looking at ways of using speech recognizers for telephony applications. Now, speech recognizers work by comparing the patterns of my voice, such as you can see on the screen behind me here, to a lot of other stored patterns. The microcomputer over the past few years has made this type of process fairly cheap and very reliable. A particular application of this is the speech recognizing telephone. and I have a prototype speech recognizing telephone here. This telephone, which in most respects is a normal telephone with a keypad, handset, transmission circuit and so forth, has got the extra facility that I can simply lift the handset, say a name, and that number will be dialed for me. So I could say, dial home, and my home number is dialed.
Martlesham's unique undersea cable laboratory is developing jointing techniques for undersea optical fiber systems. Cable, which the laboratory has subjected to the most extreme conditions it will meet in service, is stripped of its rock armor wire and the polythene insulation removed with a purpose-designed tool. A special X-ray camera is used to detect any voids or inclusions in the moldings that could cause the joint to fail in service. And the aim is to produce completed joints with a life expectancy of 25 years. The expensive electronic repeater stations needed to amplify signals are currently spaced at about 40-kilometer intervals. Experiments to reduce the number of repeaters needed have already resulted in acceptable results over 155 kilometers, and it's soon expected to break the 200-kilometer barrier. Simultaneous work on improving the amplification techniques using semiconductor lasers should also reduce the cost of long-distance communication. And advanced design methods will mean smaller, more reliable housings for submarine repeater stations.
Video conferencing is a very useful technique which allows businessmen to hold meetings in vision as well as sound. One of the problems with transmitting television pictures is that it normally takes 200 to 300 telephone lines in order to transmit a television picture. A recent development here at Martlesham has allowed us to transmit these same television pictures down only 30 telephone lines. The way that it does this is to store the background image of the picture and then transmit only the new parts to the distant end. These are shown in the white parts of the picture here. This is one of our desktop terminals. It has a hidden television camera in here. Normally, of course, you'll be looking at the people at the other end of the video conference. It also has the facility to transmit high resolution documents at the touch of a button.
This is effectively a short optical fiber of very large diameter, formed by depositing layers of glass inside a silica tube. At around 2,100 degrees centigrade, it is drawn from the furnace and coated with liquid polymer that is cured by ultraviolet light. The resulting fiber on the drum is about 1/10,000th of its original size, and after testing, ready for service. A new technique for the installation of optical fibers is to use compressed air to blow them into a tube, which will already be laid in a cable duct. The technique will speed up the installation process and enable the provision of complicated networks without the need for fiber joints. A new exciting development is a single optical fiber system that has the potential of transmitting 16,000 simultaneous telephone calls over more than 100 kilometers without the need for a repeater. Continued research in this field will enable British Telecom to respond to any future demands upon network capacity. Even further improvements in system range are possible if receiver sensitivity can be improved. Experiments in heterodyne transmission using advanced optical components and optoelectrical devices developed at Martlesham have resulted in recognizable transmissions over almost 200 kilometers without a repeater. The race is now on to develop this principle of coherent detection for commercial application.